This is Maanav, and here's my tiny file system and disk emulator. I'm just going to be going over some of the unique choices that I made, as well as some additional functionality that I introduced as part of my project. So here, I think it's easy to kind of show the hex dump and just go over some of the things that I did. So first of all, here you can see the super block where you have the magic number. And then essentially what I did in the super block is first it points to the root block, and then it can also point to the next set of free blocks, as well as how large the actual file system is. And all that is stored in block numbers or essentially the sizes in block numbers. You have to multiply by 256 to get it in bytes. But other than that, I limited the number of blocks to 64K, so you can represent the block number in 2 bytes. And I used a linked list to represent my data structure of free blocks, as well as to link inodes and data blocks together. So all the free blocks point to the next free block. The first 2 bytes in each block tells you the next block. And I use 0 to represent like a none pointer. So if it's at the end of a list, it's going to point to 0 since nothing is going to link back to the super block. The additional functionality I introduced was stats, rename, and readdir. So stat, it's going to print out the times that the file was last read, written, or created. Rename can rename an existing file, and readdir will print out everything from the root directory. So I will be showing that in my demo. Some limitations are that I use just one exception and I raise that exception with different error codes. I could have split that up probably. The linked list can cause some performance issues if you have large files. And open disk, when you're trying to reopen an existing disk, it has to be able to determine the size. So it has to read from the super block of the provided file system, or essentially from the first block. So if you provide anything that's less than 1 block size, it can cause errors, but you shouldn't be trying to reopen a disk that's less than 1 block anyways, so I think that's reasonable. And the maximum size of my file system is 16 megabytes. So now going into the demo, I'm just going to go through, I have kind of a demo all that goes through a bunch of things and prints out each step. So I'm going to run that, and then I will just go through it in the command line. So let me make this a little bit bigger. But first thing it does is it creates 3 different file systems. So you can see here there's a small disk, TinyFS disk, large disk, and it opens 3 files and it writes this to one of the files. And then it's going to seek the file pointer and start reading 3 bytes from byte 5. So it reads 567. It deletes a file, mounts another disk, and then remounts the original disk to show mounting and unmounting, and then just reads back to show like the data is static or like non-volatile. And then it calls stat to show like the stat format, and it shows the size as well as access, modify, and birth time. It can read out the root directory, which looks something like this. So there's file 1 and file 3 because we deleted file 2. And then it renames file 1 to new file and then prints out the directory again to show that it was renamed. It then sleeps and then does reading and writing and sleeps between that. So to show like stat, it does show different times for each one. So you can see they're 2 seconds apart. Other than that, I have some individual tests that I can show where they're kind of more in depth, where if you call my demo with number arguments, so 1 just makes 3 different file systems. 2 is going to open files until it can't open anymore, so it's going to basically populate the entire file system image with new files until it runs out of space. 3 is going to show that closing a file descriptor shows that you can't write to it anymore. 4 will delete a file, which will free up some space, which allows us to create a new file. And 5 will show writing to a file, and as well as writing a string that's more than multiple blocks and how that's linked together. So I think this is a good spot to do a hex dump and kind of show what it looks like. So if we look here, we have that there's no more space, so the free blocks, it just points to 0. You can see our root block that has all the different file names and the inodes, the inode numbers. You can see the data of the huge string we wrote is displayed here, and it's kind of split up because of how the allocation was, because since we freed a block in the middle. And other than that, there's not too much to see. There are a bunch of empty files. And yeah, other than that, there's a few more extra tests that show some of the extra functionality, but it's pretty much all covered in the test all. Thanks for listening. Hope you enjoyed.